Hello, I'm Cheryl. In this problem, we're asked to do three things. First of all, we're asked to find the least square regression line for the given data points -2, 0, 0, 1, and 2, 3. Then we're asked to find the sum of the square of the errors. And finally, we're supposed to use a graphing utility to help us verify our results. All right, so what is a least square regression line? Well, it's going to be the line that best fits the given data points. Well, how do we make that determination? Well, if you look at the difference between the actual data point and the point on your line, and there'll be three of them in this particular case because we have 3 points. If you square those differences and then sum them all up, you want to minimize that. So in other words, finding a least squares regression line is an optimization problem. We're looking for the minimum, and it's an optimization problem of a function of 2 variables. Well, instead of going ahead and doing the optimization problem, I know that for n data points, I can get the equation y equals ax plus b. I can figure out what a and b is by using these formulas. So instead of starting from scratch with the minimization problem, I'm just going to go ahead and use the general result for my particular situation. So in this particular case, we have 3 data points. So we're going to begin by saying that n is going to equal 3. Now, if you look at your formulas for both a and b, a being the slope of my line and b being the y-intercept, notice we need several things. We need to sum up all the x values. We need to sum up the y values. We need to sum up the product of the x and the y values. And then there's a spot here where we have to do the sum of the square of the x terms. So I'm going to go ahead and use a table to help me collect all of that information. So let's begin by collecting all of the x values. And for my data points, my x values are going to be -2, 0, and 2. My y values are going to be 0, 1, and 3. Okay. I'm also going to need the product. So -2 times 0, that's 0. 0 times 1, that's 0. 2 times 3 is 6. And I'm also going to need the x squared. So -2 squared is 4. 0 squared is 0. And 2 squared is 4. Now remember, in my formulas, I'm going to need the sums of these different values. So let's start out with doing the sum from I equals 1 to 3 of x sub I. So I'm going to sum up all these terms. -2 plus 0 plus 2, that's all equal to 0. Now let's sum I equals 1 to 3 of y sub I. 0 plus 1 plus 3, that's 4. We'll do the sum from I equals 1 to 3 of x sub I, y sub I. 0 plus 0 plus 6, that's 6. And finally, we'll sum up I equal 1 to 3 of x sub I squared. So that will be 4 plus 0 plus 4, which is going to be 8. Okay, so let's take all this information and plug it into my formula so that I can calculate the slope of my line. So my slope then is going to be n, which is 3, times the sum from I equal 1 to 3 of my product. So that's going to be 6. I'm then going to subtract my sum where I'm adding up the x terms. And so that's going to be 0 times the sum of my y terms, which is 4. I divide all of that by 3 times the sum of my square terms. That was 8. And then I'm going to subtract the sum of my x terms, which is 0, and square that value. Okay. So that's going to give me 18 minus 0, so that's 18, all over 3 times 8, which is 24 minus 0. So that's 24. 6 divides evenly into both of those, and I end up with a slope of 3/4. Okay, now let's go ahead and get the y-intercept. So for the y-intercept, the b term is going to be 1/3 times, this is the sum of my y terms, which I know is 4, minus a, which I've already calculated to be 3/4, times the sum of my x terms, which is 0. And this is going to be 1/3 times 4, or 4/3. So now I have the equation of my least squares line, and it's going to be y equals 3/4 x plus 4/3. Okay, that completes the first part of my problem. Now I need to look at the sum of the squares of my errors. So how do I do that? Well, remember, I've got 3 terms here. So what I'm going to be doing is I'm going to be taking f of x1 and subtracting y sub 1 from it. So in other words, I'm calculating the f of x sub 1, this data point. The y sub 1 gives me the y coordinate of that point. When I subtract them, I get that distance. So I'll take that difference and square it. Then I'm going to do the same thing for the other data points. So this will be f of x sub 2 minus y sub 2 squared plus f of x sub 3 minus y sub 3 quantity squared. Okay, so in this particular case, I'm going to be taking f of -2 and subtracting y sub 1, which is 0. In fact, I can get those data points right from my table, so I'll subtract 0 and square it. I'm going to be taking f of 0 and subtracting 1, and then squaring that result. Then I'll be taking f of 2 and subtracting 3 and squaring that result. So I'll go ahead and I'll plug -2 into my function. So I'll have 3/4 times -2 plus 4/3. Then I'm subtracting 0. So I have that quantity squared. When I plug 0 into my function, I'll have 3/4 times 0 plus 4/3, so that'll just be 4/3, and I subtract 1 and square my result. I'm going to plug 2 into my function, so that's 3/4 times 2 plus 4/3, and then I'm going to subtract 3 and square my result. At this point, we have a lot of arithmetic to do, but the result is 1/6. So finally, we're going to use a graphing utility to help me verify my result. You can do this by using the statistical package, and we're going to enter 2 lists. The first list will be all of the x coordinates of my data points. The second list will consist of the coordinates of the y coordinates of my data list. So when I enter the lists, I'll enter -2, 0, 2, and then for the second list, 0, 1, 3. Then I can go ahead and use the calculate feature of my statistical package, come down and find something called linear regression. And then when I hit enter, it will give me y equals ax plus b, where it tells me that the a is 0.75, which is exactly what I came up with 3/4 for my slope, and that b is 1.333 with that 3 repeating, and that's what I have as my y-intercept of 4/3. So I verified that what I calculated was correct. I hope that was helpful. Thanks.